in this particular question, we have a probability that probably mixes in a few different concepts from normal distribution, as well as the fact that you want to get binomial involved as well. So it might be a little bit more challenging, perhaps, if you're not familiar, but just break it down the question bit by bit, and we should be able to do it. So we have a machine. It packages 1 kilogram bags of flour, calibrated to the mean of 1.1 kilograms and a standard deviation of 0.05 kilograms. Now, you're not really told the distribution specifically, but generally you can probably assume that it's normal distribution if you're not told. And secondly, with a large enough sample of which you have a machine, you can assume that overall the normal distribution is a good approximation to the distribution as n goes to infinity, even if it's not a normal distribution. So for all intents and purposes, treat it as a normal distribution. So we have a normal distribution with a mean of 1.1 and a sigma of 0.05. So your weight, which we'll call x, is distributed normal with 0.1, 0.05. A bag is deemed acceptable if the weight is greater than or equal to 1 kilogram. And then you take a sample of 10 bags and you want to work out the probability. So ignore that part for the moment. Let's just focus on one bag. Okay, so you've got a mean of 1.1 and a standard deviation of 0.05, and you are okay, it is deemed acceptable if it is greater than 1 kilogram. So you probably want to firstly work out 1 kilogram, well, where is that relative to 1.1? So your mean is 1.1. Your cutoff is at 1 kilogram. Your standard deviation is 0.05. So you would expect your graph to look something like this in very rough terms. Okay, in very rough terms. So in other words, you would agree, or you should have some sort of idea that most of your bags will be okay based on your standards. Most of your bags will be okay. And these bags down here would be the ones you would reject. So we really want to find a probability for one particular bag, whether it's going to be accepted or rejected. You need your normal distribution to do that. Now, this question is actually reasonably easy, and you probably don't need to do too many calculations here. And the reason for that is because 1 kilogram, you want to think of how many standard deviations that is. So if this is your mu, one standard deviation is going to be 1.15. Two standard deviations is going to be 1.2. And one standard deviation below is going to be 1.05. And two standard deviations below is going to be, well, 1. So your 1 kilogram over here is 2 standard deviations below. And so the only ones that aren't going to be, that are going to be rejected basically is when your x is going to be less than 2 standard deviations below your mu, right? Which really means, I mean, z being less than -2 in terms of a z score. And you kind of should know that even without looking up the table, because you know that one standard deviation is about 68%. Within that, 2 standard deviations is about 95%, give or take a tiny bit. And so because the left-hand side and the right-hand side are equal, then the reject should really be 2.5%. So we can do this formally with the z-score, we can show you with the graphs, but we're really essentially saying that your probability of acceptance is 97.5%, and your probability of reject is not okay is 2.5%. That's what we expect. And let's show you that with a few graphs, computer-generated graphs to sort of help. So here's your normal distribution, okay? And right now it's the standard normal. So if we go down a bit and we want to get below, okay? So if we just want to get below and you got your z-score, below your z-score, 1.96 is the proper one, but we worked out a z-score of -2, okay? So that's representing that aspect of the graph. Okay, so we're getting below -2. That's this aspect. And so how do we get -2? If you want to use your formulas, then your z-score must equal what you want minus mu divided by sigma, which was 1 minus 1.1 divided by 0.05, which is of course -0.1 over 0.05, which is -2. In other words, it was 2 standard deviations below. So that was the idea. And if you specify that, then you can see that the results is, if you're using a calculator, 0.0228. So not exactly 0.025, but that is the idea. So if you were above -2, this is the accept, the bags you would accept. And that you can see is 0.9972. And for your reject, below, it will be the rest. So we're basically using this to get your probability. Now we've converted into a z-score, but we actually didn't even need to do that if you have the the tools in front of you. In an exam, you should do it. But if it's 1.1, and we'll just show you why it works. So if you have a normal distribution with 1.1 and 0.05, you can see we've kind of got the same graph, but we just changed the labels. Because now we want it to be below 1, it is the same graph. We change the numbers down here. This is mu minus sigma, mu minus 2 sigma. We've essentially just changed the labels, but everything's still really the same. And if you really want to be above 1 kilogram, it's still accept. And so you've got 0.9972. Okay, so we will just use the fact that you've got 0.9972 as our answer here. So basically all of that has now worked out that the probability of accepting a bag that is made by the machine is 0.9972. 9772, I should say. If you use 975, you should probably be accepted because that should be fine as well. And the probability of reject is 0. Well, the converse, so 0.228. And we're now taking a look at the rest of the question. So if we go back to what the question actually said, we can now focus on the next part. The question now says you take 10 bags and you want the probability at least 8 bags are acceptable weight. So this is now where you apply your probability theory. So you take 10 bags and you want at least 8 bags. Now, at least 8 bags basically means you've got 8, 9, or 10, which is probably easier to do than 1 minus all the rest. So probability of at least 8 equals the probability of 8 acceptable plus the probability of 9 acceptable plus the probability of 10 acceptable. And each of these is basically just a binomial. You can treat this as your P for accept, Q for reject. In this case, your N is 10. You've got 10 bags. Don't forget your NCR. So this is going to be 10C8. I'll just write it as P to the power of 8 Q all squared plus 10C9 P to the power of 9 Q to the power of 1 plus 10C10 P to the power of 10 Q to the power of 0. Okay, sub those numbers in and you should get your answer. So don't just do the powers of P and Q. Okay, you do need to take into account the fact that when you're doing 9 bags, it could be the first bag that failed, the second bag that failed, the third bag. It could be any of the bags that failed. So there's 10 different ways to fall into this category. And there are, well, 45 different ways to fall into this category. Okay, so a little bit of calculator work. And we get an answer of 0.9987. As to, well, to 4 decimal places. And we would expect that because given that each individual bag has a very high chance of being accepted, the chances of having most of the bags being acceptable is very high. So that's basically how you do the question. Nice and easy.